Another important part of graphing is to talk about slope. And in fact, when you guys get to calculus, basically everything you do has to deal with slope. Slope of curved lines, all that sort of stuff is all calculus is. So we're going to start off with basics though and just refresh ourselves on slope of a straight line. So just as a reminder, slope refers to the steepness of that line. How fast is it inclining, or how fast is it declining? Okay, is it positive or negative, in other words? It can also be expressed as the change of y, how far you're rising up, over the change in x, how far you are running. So here is the description: vertical change over horizontal change. I like to think of this almost as a stair step. So how far are you going up over how far are you going to the right? So how steep are those stairs, essentially, right? Okay, the flatter they are, the less steep they are. If they go up like this, I'm probably going to break my neck because I'm going up some steep set of stairs. Okay, let's not have those set. So again, you just take your rise over your run if you're doing this graphically, and then you'll just have a fraction. And the thing to note is it is better to keep those as a fraction because the slope tells you how much each step you should be going up, and then how far each step you should be going to the right. So if you have a graph, use that rise over run formula, just go count up and then over. But let's say you don't have a graph and instead you just have 2 points that are on the line. How are you going to find the slope? Well, they actually have a formula that you can use, and it actually comes from the 2 numbers here are the rise, your change in y, hence they subtracted, over the change in x, which is your run. So it's actually rise over run. We've just put in those points or those coordinates that we have, those x and y coordinates. Notice in here they do list the y2 first and then you're subtracting y1. Just as long as you keep this consistent, it's fine. Okay, so y2 minus y1 over x2 minus 1, x1. If you had flipped those and done x1 minus x2, you just got to make sure you do the same for y1 minus y2. And of course you want to reduce that fraction if you can. So here's a graph. So we can go ahead and just use that slope, which we use the variable m for slope, rise over run. Run, not run, this isn't Pirates of the Caribbean. Okay. Where's your mind at? Okay. So just grab the leftmost point and we want to make a little right triangle between the 2 points given. And you can pick any 2 points on that line and that should be a true statement. So your rise, if we were going up, it would be positive, but since we're going down, and in fact we're going down 1, 2 spots, this is going to be a negative 2 for the rise. We're going to be going down 2. And then the run is 1, 2, 3, 4. So you're running 4 this time. 4. And the run I always like to keep positive because we're always going to go to the right. And then we reduce. Both of these are divisible by 2, so it's just negative 1/2. In other words, to get from one point to another, you just go down 1 over 1, 2. There's a point on the line. Down 1 over 1, 2. There's another point, and you could keep going like this. Create those little stairs to tell you how steep that line is. Okay, now let's do it where we aren't given a graph and instead we're giving the slope of the line. Well, we're trying to find the slope of the line. We're given 2 points. Now we could do what we've done before, which is label those points x1, y1. Remember that just is the first point, x1, y1, just the x and y coordinates from the first point. Don't overthink that, x2, y2, just a way to label them. So we're going to use that formula m equals y2 minus y1 all over x2 minus x1. Remember, it doesn't hurt to rewrite that formula either because it helps us to remember that the more times we write it. Okay, y2, -2 minus y1, -5. Notice I'm very careful about that double negative again because it pops up all the time, right? And then on the bottom we have x2, -1, -3. Okay, now we just need to simplify the top. This becomes -2 plus 5 because those two negatives combine to make a plus. And this one would stay the same. So -2 plus 5 is +3. -1 minus 3 is -4. And I'm just going to float the negative to the top. One negative stays negative. It doesn't matter if it's on the bottom or top. So this means we go down 3 to the right 4, right? We're going down 3, 1, 2, 3, to the right 1, 2, 3, 4. So our slope, if I could draw a straight line, our line would look something like that. It's going downwards because it's a negative, and we're going down 3 over 4 for each one. And you can actually use GeoGebra to help you check that you've done the slope correctly. And I'm going to show you how to do that real quick. We can just go ahead and graph those points just like we did in the previous. So grab that point, 3, -5, 3, -5, and my other point is -1, -2. -1, -2. Now this time, since I'm trying to find the slope of the line, instead of using that line segment like we did last time, I'm just going to click that down arrow and actually use the line here. So we're actually going to create a line. So just click on those 2 points. And notice this time it goes all the way through. That indicates that that is a line. Now you could go ahead and once you've graphed these, we could do the rise over the run. So we're dropping down 1, 2, 3, and then we're running 1, 2, 3, 4. That's acceptable. Or if you look over here, the line, they're going to give you the formula for a line. And if we right click on it, we can change the format to the slope intercept form, y equals mx plus b. If we click on that, notice it changes y equals -0.75x minus 2.75. That number in front of x is going to indicate your slope. -0.75 is the same thing as -3/4. They just changed it into a decimal. But that is how you could check your slope. So play around with that connection between the points and graphing. It's a really crucial thing to understand as you're moving forward in mathematics. So give it a try, play around with different numbers. You can even move your points to see how it affects your slope, right? Make sure it connects. Oh, this one's still -0.75. What if we brought it over here? Oh, actually the slope is +1 now. Just play around with those, you know, it's kind of fun just to mess around with it. Give it a try. Let me know what you think.